A butterfly flaps its wings in Brazil, and a tornado forms in Texas. What if the world is not as orderly as we once thought? What if beneath the surface of apparent randomness there is a hidden structure, an unseen force shaping everything from the weather to our very lives? This is chaos theory. At its core, chaos theory is the study of complex systems that appear disordered but follow underlying patterns and rules. It is not about pure randomness. It is about hidden order within apparent chaos. It suggests that tiny changes in initial conditions can lead to vastly different outcomes, making long-term predictions impossible in certain systems. This concept has transformed mathematics, physics, economics, biology, and even philosophy. But where did it all begin? The seeds of chaos theory were first planted in the late 19th century by Henri Poincaré, a French mathematician who studied the motion of celestial bodies. He realized that small variations in initial conditions could make long-term predictions impossible in complex systems. This shattered the classical Newtonian belief that the universe operated like a perfectly predictable machine. Poincaré wrote, "It may happen that small differences in the initial conditions produce very great ones in the final phenomena." Though his ideas were revolutionary, they remained buried in mathematical circles for decades. Then came the 20th century, and a man named Edward Lorenz. In 1961, meteorologist Edward Lorenz was running weather simulations on an early computer at the Massachusetts Institute of Technology. He entered a rounded-off decimal, 0.506 instead of 0.506127, expecting only a slight difference in the results. But to his shock, the simulation produced widely different weather patterns. A minuscule change had led to an entirely unpredictable outcome. This phenomenon became known as the butterfly effect. The idea that small changes in a system can lead to massive consequences. Lorenz published his findings in 1972 under the now famous title, "Does the flap of a butterfly's wings in Brazil set off a tornado in Texas?" It was a poetic way of describing a scientific truth. Even the most complex systems are sensitive to their beginnings. Chaos theory isn't just about weather patterns. It has a visual side, an infinite, mesmerizing world of self-replicating patterns known as fractals. In the 1970s, Polish-French mathematician Benoit Mandelbrot discovered that nature itself was filled with fractal geometry. The jagged edges of coastlines, the branching of trees, the veins in a leaf, and the structure of galaxies. Mandelbrot's work showed that even in apparent disorder, nature follows deep, repeating patterns. His famous quote, "Clouds are not spheres, mountains are not cones, coastlines are not circles, and bark is not smooth, nor does lightning travel in a straight line." Fractals became a new way to see the world, revealing the beauty of chaos in everything, from biological growth to financial markets. Chaos theory is not just abstract mathematics. It affects every aspect of our lives. The weather, for instance, is one of the most chaotic systems in existence. This is why meteorologists struggle to predict long-term forecasts. Tiny changes in atmospheric conditions can create dramatically different outcomes. Markets rise and fall based on countless unpredictable factors. Economists use chaos theory to analyze trends, but ultimate predictions remain elusive. On the other hand, heartbeat irregularities, the spread of diseases, and even neural activity in the brain follow chaotic patterns. The choices we make on a personal or global level can ripple through history. Chaos reminds us all small actions matter. So, what can we learn from chaos theory? Number one, uncertainty is a fundamental part of life. We like to believe we control the world, but chaos theory teaches us that uncertainty is inescapable. Instead of resisting it, we must learn to adapt. Small changes can have big effects. The butterfly effect reminds us that even minor decisions can shape our lives in ways we can't foresee. Look for patterns in chaos, as nature may seem random, but beneath the surface, there is structure. Recognizing these patterns can help us navigate uncertainty. Finally, be open to new perspectives. Chaos theory shattered the rigid scientific ideas of the past. It teaches us that new ways of thinking can revolutionize how we understand the world. Chaos is not destruction. Chaos is creation. From the motion of galaxies to the beating of our hearts, chaos is woven into the very fabric of existence. So, the next time you see a storm brewing, a ripple in a pond, or a decision before you, remember that even the smallest forces can shape the universe. What impact will you have?